Well, yeah, nice to meet you guys. Yeah, I'm planning to talk a little bit about just what sort of connecting the shop can look like with technology and what some of the benefits of that are. I'm not really planning to talk much about like Fulcrum or who we are or that type of thing. This isn't like a promotional moment for me, but really talking much more just about in general kind of why now? Like, why does now this moment feel more critical to start using tech in the shop and specifically in like the business side of things? And then what does that actually look like in the shop? And then mostly really want to just leave you with a few frameworks of how to think about that decision and where it may or may not actually make the most sense. So yeah, that's kind of what I'm planning to cover. And then obviously I'll open up any questions even as I go along. Definitely feel free to just chime anything in. Cool. So this is actually a quote from Kirk, who is one of our customers in Ohio, and I think he kind of summed up the situation that we're in right now really well. In a conversation we had with him, kind of saying, my machines can make things faster than I can even decide what to put on them. And I think what he's sort of alluding to here, and something we talk about a lot like internally at Fulcrum, is just we're at a point where the machines and the equipment and everything on the shop floor is advanced so far past everything that's happening on the business side and the tech and sort of thought that's been put into that side of the business. The machine side has advanced so much, and the other side is now the piece that's sort of lagging behind and is where that constraint is. It's actually in the brains of the business and that decision making, whether that's scheduling or purchasing planning decisions or just general day-to-day decisions that people are sort of having to make. So yeah, backing up a little bit in terms of like why though, like how did we get to this point and why is this point so much different in this moment in time in terms of that amount of decisions actually that need to be made on a day-to-day basis. So if we step back a little bit, just the amount of advancement that we've made in the past decades, also just hundreds of years, is pretty astonishing. So going from 100 years ago, the first ever like liquid fueled rocket, to starting to send people into space, to now having reusable boosters. We see this across so many different industries. The way that we've actually advanced means all of these products are so much more complicated than they were before, even 10 or 20 years ago. So you see it in space, you see it in automotive. We've made really big changes. Obviously the Cybertruck is a very big change in terms of what we think of from design of a vehicle. But I think just exemplifies again how much we're continuing to change all of these like products, and all the way into more industrial spaces, like buildings, and building massive construction like this. So I think put more simply, really what's happening today is that the things that we're creating are much more complicated than they ever were. They require much more precision than they did before, and they're changing much faster than they were before. And so as a contract manufacturer, someone in the middle of that supply chain, what that really means is your customers' requirements are harder, more precise, and they change much faster and much more rapidly than they have in the past. And so absorbing all of that change into your business means that you have more decisions that you have to make on a daily basis than you had to make maybe even 10, 15, 20 years ago. And so the other sort of natural question with a lot of this progression then is, okay, is this gonna just stop or like plateau? And a lot of people think no, probably not. I think The Economist, if you were at his speech earlier, he kind of talked a lot about just how much investment is going into the development of things like AI and computational power and growth and that type of thing. But this is actually a graph of Moore's Law. who was the co-founder of Intel, and back in the 60s, he basically said that the number of transistors in a computer chip will double every 2 years, and it has continually since then, and we sort of expect this to continue onward. And really, what that just means is there's more and more computational power in these chips. And the reason that that matters is we can just do a lot more with those, especially in terms of scientific research that we couldn't do before. And so the power of those chips allows us to unlock more and new research in different sciences, whether it's oil exploration, all the way to, you know, things within medical research, which then in turn sort of fuels new innovations in devices or medical devices or whatever it may be. So as we continue to develop these chips, we just advance science, we advance the innovation, and sort of continue this evolution of all of the products of everything that your guys's, you know, components are sort of going into. So yeah, we expect that to actually only get, I shouldn't say worse, but faster in terms of the amount of change that you're having to sort of absorb. The other component that isn't necessarily new, but I think is a factor in understanding the amount of ambiguity and change that we absorb here in the way that we have manufacturing set up in the United States and most Western countries, is that it's this network. And so you have a few really big raw material vendors and suppliers sort of on one end of the network, and then you have some of the larger players like a Boeing or something like that on the other end. But really the way that we produce things in this system is taking something really, really large, and then we split it up and say, okay, you're gonna do this component and you're gonna do that component and I'm gonna do this component, and it's all gonna be to spec and it's gonna come together at the right time, which is in contrast to other systems of manufacturing where there's actually fewer but larger players that centralize sort of a lot of that into one space. So our method and system of doing things has a lot of advantages. Because we split it up like this, we have way more small to mid-sized manufacturers, which actually increases competition, which increases innovation. And so I think this system has a ton of advantages, but it also makes it really complicated to coordinate amongst everyone in it, and different changes sort of vibrate across the system more than they would in maybe others that are a bit more centralized. And so I think one of the biggest sort of, a good example of the benefits of this particular system, again, isn't new, but sort of just dates back to the space race. So, JFK said, hey, we're going to space. I want you guys to make it happen. And from there, we basically took 400,000 people across 26,000 different manufacturers, and we're able to pull that together and make it happen, put someone, on the moon. But this method, while it has tons of benefits, and I think is really, really proven, is another reason that it is more complex for us to operate, and there's much more sort of coordination happening between all of these businesses, which also translates into coordination cost within your own business. So thinking back a little bit to, okay, well, what does this look like inside your business? What does this coordination cost actually look like? And how does this tie back to how technology can help sort of alleviate some of those coordination costs? So this is sort of just a well-studied concept, especially in software engineering. We talk about this a lot. But as you add, after a certain size, so roughly around a little bit less than like 10 people or so, after a certain size, as you add another person to a project or to a business or to a company, the output doesn't increase linearly anymore. It starts to increase at the square root of n. And so, it makes sense if you just obviously think about it conceptually. I'm sure you feel it whenever you're at a business size of 10. Everyone can look around and just see what's going on. Everyone knows what's happening. You can make decisions pretty fluidly. It's pretty clear kind of what you need to do. As the business grows, as you get more and more people, that becomes less clear, and people spend more and more of their time just trying to coordinate their efforts amongst one another, rather than actually putting their time and energy into the product or the thing that you're making or the craft or innovating a new way to do something. Those are the things that are actually adding value to your business, but you end up spending an increasing amount of time just coordinating between all these people and these efforts. And that's the spot where actually this connected sort of piece of technology can actually help. It can reduce all of that coordination cost. And so that's really kind of the goal of it, is to combat the coordination cost. And so here on this slide, I have Fulcrum on here. You can think of this as any ERP system, centralized system. But that's what it's trying to do, is essentially trying to take this bottom line and push it up so that you're getting more out of your team, your people. They're spending less time actually doing all of this coordination effort, and the system and the machine is doing a lot of that effort for you. So I think there's a couple things that I would break down whenever you're thinking about connecting your shop together, and sort of a couple different steps in order of operations and trying to make some of that happen. I think the first is maybe obvious or goes without saying, but embracing change is a really key component in kind of two ways. Everything that your business is producing is really, it's your ability to adapt. It's your ability to add your own special innovation or craft to it. Anyone can buy machines, anyone can hire people. Like, you're providing this unique craft on top of all of that sets you apart from the people around you. And a lot of what you're actually creating there is a way to adapt to the market, to what people need or what people want. So everything that you've been doing up to this point has been about embracing change. This is just another step in that sort of journey of continuing to embrace change and adapting your business for this sort of next phase. But I think even more important than that point is just when you're thinking about adding tech into the shop, sometimes that can be really scary or overwhelming. It can be a lot of work. There's a lot that kind of goes into it, especially if you're thinking about implementing a system for the first time. But really being out there as the one leading that with your team and showing them it's okay. Change is scary, but it's going to be all right. Maybe seems like a small gesture, but is absolutely huge in getting people on board and comfortable with making some sort of larger scale like change like that. The second sort of component to think about is connecting the shop isn't just about automating things. A lot of it, and really the first key step, is just about codifying the knowledge that's in your team's heads and brains. A lot of what people's shops today look like something like this. There's people who are in the middle of everything, and they're the ones who are making everything happen, and that should be valued. And the first step in my mind of even before getting to the technology is actually just understanding this and making sense of it. Understanding who is doing what and realizing that nothing in your business is obviously just happening magically, smoothly. Like if something is smooth, someone is doing something there that's right, and you should go find it and understand it and document it or write it down or really get to a root of understanding of what's actually happening there. And then take that and put it in some central thing. So when we talk about a system, there's obviously lots of software systems and things out there. Even just at the lowest tech side of it, just some way that everyone can see and access that knowledge, whether it is in just some sort of document form or whatever, but that removes these information silos. Everything that's in just one person's head is a little silo in that picture, and no one else has access to it. They can't read each other's brains. There's no way for them to get it. And then that's what's causing all this coordination tax, because they have to constantly run into each other to go get that information and do something with it and make a decision. And so kind of taking all of that, ideally like digitizing it in some way, allows you to create one sort of central knowledge repository. And so with that, you get two things. You get people who can make better decisions independently because they have access to the information that they need. It's readily available. But then you can use that to start on that second step, which is the automation of the decision making, whether that's production scheduling or actually calculating purchasing planning. Like those types of things need the data and the input to actually happen. So it's somewhat like sequential in that nature of getting everything into a shared space, and then you can start to use all of that digitized information to actually automate things. But even without the automation, you'll see benefits of just having the centralized information. The other sort of framework or concept to think a little bit about is that how you should expect to interact with technology is somewhat situational. So I think we talk a ton about automation, but not everything should be automated, at least not for where we are right now with technology. And so I think it's helpful to think a little bit more about what you expect from technology in different areas, maybe of your business or of your shop. So there's some things that humans are really good at. There's some things obviously that humans are really bad at. There's other things that computers are really good at. There's other things that computers are really bad at. So in that quadrant where maybe a human is really good at it, but a computer is really bad at it, what you really want from the technology you're interacting with is just really easy input, because you're just going to take something that your brain figured out that the computer couldn't, and you're just going to get it in there as fast as possible. So again, you still have that shared repository, but you're not expecting the computer to come up with the solution for you. And examples I think right now of that are basically figuring out like how to build something. We're not at a point where computers are good at just reading a drawing and spitting out the exact specifications of the routing and all of the bill of materials. We're getting closer to it. Even at Fulcrum, we have tools that are much closer to it, but we still can't automate that entire experience away. It requires the human. The other quadrant in the top right, in the top right, so where a human is actually good and the computer is good. In that situation, you're looking for more of an interface with the computer where you have what I would call it control, where you can tell what the computer is doing and understand, maybe it's math or logic or whatever, because you're also good at it. You're still letting it do it, but you want a little more like control over it as well. Versus in that bottom quadrant where it's automate, the computer is really good at it. Humans are bad at it. We're not as good at math as computers are. If you think about a production schedule, it's really a lot of math and like dates. And that's kind of it. And so, while that's complex for us, that's a spot where we really should just let the computer do its job and not try to influence it as much. Just take the output and sort of run with it and trust it. And then you have the quadrant where we're both bad at it. So in that situation, I think of it more like a co-pilot. It's more so that neither of you can come up with the answer on your own. So you'll need to maybe put stuff in and get an answer back, and put stuff in and get an answer back. A simplified example of that is probably more like a calculator. Like the calculator isn't solving the full problem on its own. You're also not solving the full problem on your own. Like you're putting something in and getting something back, putting something in and getting something back. So I think this is just sort of meant to be a framework to think about what you're expecting from the technology that you're implementing in those areas. And as you're like evaluating as well, like what you're trying to actually like get out of it. Do you want it to be able to give you an answer, or do you just want it to be able to maybe be an easy interface that you can just dump information into? And those are two, different things. So yeah, kind of just to summarize a little bit, as you're thinking about connecting the shop together, really what you're trying to do is you're getting all of the knowledge, putting it in a central spot, doing something with it, whether it's automation or just allowing people to make better decisions. But ultimately, you're just trying to move that line up and remove some of the coordination costs that continues to build and build and build sort of in the business. And there's a lot of definitions of what's like ERP, but we don't do accounting, but we're handling everything from order management all the way into production management, scheduling, purchasing, inventory. Yep. So pretty much all of a lot of those edges of what people would consider an MEP, an ERP. There's a MES, MRP, all of those like acronyms. But yeah, what we really focus on is that connecting the shop together, trying to make data really easy to get in so that it can be shared, and speed up the communication. So yeah, thanks guys.